All right, everyone. I am here with Francesc Riera. Francesc is an applied machine learning engineer at the Lego Group. Francesc, welcome to the TWiML AI podcast.
Thanks, and thanks a lot for having me as well, Sam. I think it's a pleasure, and super excited about the talk tonight as well. Well,
Same
I
here,
guess
same here. And thanks for taking the call at night or being on at night. It's a bit later for you. You're in Denmark.
yeah, that's correct. Denmark. Well, as you know, the headquarters for Lego was born in the small town of Billund here in Denmark. So living just across it.
Very nice, very nice. Why don't we get started by having you share a little bit about your background and how you came to work in machine learning and at Lego?
Yeah. So well, I think it's not going to be a very long story, right? Because I've been on the market for roughly 3 years now. But I think my enthusiasm for ML, and actually I should say my enthusiasm for computer vision, started back in my bachelor's in industrial electronics in Spain, and that's just because I was studying the bachelor's in electronics, and then the last semester was focusing on robotics, and then in robotics we had an introduction to computer vision, and I really don't know why, but I thought this is damn impressive. It's super interesting what you can do, well, in reality with mathematics and then matrices, right? For all the pictures and pixel values and all of these sort of things. And then that drove me to then actually catching up on a master's in Denmark. So that's when I moved to Denmark to do a full-on master's in computer vision and machine learning in the University of Aalborg, which is here in the north of Denmark. And after that, well, I guess I become sort of an expert in the matter. I hope so, at least. And that got me then. Yeah, I got a small job as a software engineer for a couple of months. It was not my thing, and then I found this splendid opportunity at Lego where I got to actually work with ML on active products running in the cloud as well.
Awesome. Awesome. Well, speaking of industrial robotics and computer vision, one of the early, I think this was, uh, I think this was early many years ago. Demos of AI was like somebody built a Lego sorter using like a treadmill kind of thing and a paddle or some kind of robot that would like sort the Legos into different pieces. Did you ever have you ever seen that one?
It's funny you mention it. We are trying to undick that one from the internet to maybe exploring the options also to use it as a product for us.
Oh, really?
It's quite funny that you actually mentioned it. I think we talked about it 2 3 weeks ago. So
Oh, that's funny. I
yeah,
if I remember correctly, I remember reading a hacker news thread when this was published. Again, I think it was probably like 5 years ago or 4 years ago or something. And there were apparently a bunch of people that would like go on eBay and buy these gigantic bags of miscellaneous Legos, and they were talking about using these kinds of devices to sort them and then resell them. And like apparently there's a bit of a cottage market, so to speak, in remarketing Legos.
yeah, and it's also one of the big campaigns, right, that we are also running is even though Lego is primarily made of plastic, right? So you want to give your bricks the longest life ever, right? And I mean,
Hmm.
if you had some Lego set from the 50s or the 60s, you could still probably use it today.
Hmm.
So I think that's also what drives this enthusiasm, right? And on you being able to, all right, let's try and make this, circular economy in a way, right, for the brick.
Yeah, yeah. Well, I brought that up not thinking that it was something that you were actually thinking about. But maybe we can jump into how ML is actually used today at Lego.
Yeah, so maybe I can just start, yeah, presenting slightly my area. So my team going from I guess the bottom to the highest. So I'm part of a team where we are three ML engineers, and then full stack, and then all of the surroundings, right? And in my team we have two main products, which I can just quickly describe now. We can go into details a bit later if you want as well. So the main product that started also now 2.5 years ago, approximately, it's a moderation service. Um, so as you know, Lego is of course a brand for aimed at children, right? And children are our main responsibility. So of course, all of these, for example, social media applications or games or anything where children can upload their content, let's say images, text, videos, anything that can be shared and can be created by them on the phone or on the computer needs to be moderated by law before it's actually available or online for other children to see, right? As to avoid the obvious things, right? And I mean, we know Facebook does that. We know Instagram does that. A lot of companies do it, but not in the level I would say as Lego does it. And that's because on Facebook, you could post something that is obscene and it's not necessarily going to be deleted as you upload it, but it's going to be deleted after the fact, maybe because somebody reported you, right? That cannot happen in our applications because the damage could already be inflicted, and that's not. It's definitely not the image you want to give to the brand. So yeah, so our product, what it does is receives the content created by the users, and we do an initial pre-filtering of this content. So on images, on text, and on videos, we try to reject already what is the most obvious things that should not be on the app. Like if you upload a very bad quality image, if you show your face or some sort of identifiable information, you cannot also share that. So we also remove that. Of course, the obvious profanities, and we are working also on extending a couple more detectors. And detectors, by detectors, I mean machine learning algorithms, actually. So we do this pre-filtering. What gets rejected by us just gets feedback to the user saying, "Hey, we are very sorry, but your creation is not allowed because of this. Try to take a new picture or try to be nice writing the text." Some positive reinforcement. If the content is approved by us, it then goes to manual moderation. So there's a company moderating every single piece of content before it is published. So what we accomplish with our product, right, is, well, of course, there's two things, right? One of them being monetary aspect, because each piece of content that is very obvious does not need to go to a moderator. That costs per piece, right? So in that sense, that's what we managed to prove. And of course, if let's say there's like a, I don't know, a big fair with Lego, and people are asked to upload pictures because they are in the fair. It's like, oh, you need to build a car, and then you need to post a picture of the car. So of course they would like to post a picture, but if the picture was bad for some reason, it would be nice that they get the feedback instantly rather than having to wait. So when it goes to manual moderation, there is a time frame of 5 minutes. I think it's 5 to 15. I'm not 100% sure because it's not my part, but the thing is, our service provides a response under 10 seconds for whatever type of content. So if you uploaded something, let's say you take a selfie with your car, it's like, oh, we really like your car, but you cannot have your face there. So they get the response in seconds, like, oh yeah, my car is still here. I take another picture. Life's good again, right? And then the second product we have. So after everything has been approved, so when your creation is live on the social media app, then we have an automatic job every morning that will take all of the creations from the users, and then again with two sorts of algorithms, so one for image and one for text, we try to identify what is the theme, the predominant theme on the creation. So, for example, you are a big Star Wars fan, then you have a lot of Star Wars sets. You take a picture of your Star Wars set. We probably will identify it as Star Wars, and then what we do is like, okay, this kid has uploaded a Star Wars picture or Star Wars album collection. So what we do is then we send a like with NPCs on the application, and we also use different NPCs to send comments, reinforcing them and encouraging them to keep building, saying, "Oh, that's a very nice Star Wars creation you have. I would love to see more from you, and similar like that.
And the NPCs are bots or characters in the.
Yeah, it's they've already existed in the app,
Mhm.
and they've been used. So before we set up this environment or this product, it was used by people. So me as a, I guess, consumer engager person or in the team, I would go in, I would log in as the, let's say, Chihuahua, and then I would comment out on a couple of things.
Okay.
So now what we're doing is we are automating the job. Of course, there's still some people looking at the comments and maybe doing more specific comments depending on the scenario. But it's been proven also to actually give a lot of value because we receive a lot of uploads saying, "Oh, look, Lego Life Emmet liked my comment, liked my post," and
Yeah.
they are super happy, right? So it's also very fulfilling for us as well to see that the reactions are positive, right?
Hmm. Hmm.
Yeah.
And you mentioned there are three ML engineers on that team.
Yeah.
Hmm. And what's kind of the broader size or scope of ML and data at Lego?
Well, so back in March, we had also a big reorganization where we then founded also what is now the department called the data office.
Okay.
So my team resides within the data office and then the data science products. But from the data science products, for example, we have a couple of others. So of course, in the Lego.com page, where you go to the shop, right, and you buy a Star Wars set, we have, of course, a recommended engine saying, "Oh, you like the Death Star, maybe you're also interested in the X-wing," right? So the recommender team is also, I guess, our sister team working using data as well and developing ML solutions. There's also two other product teams. One working on marketing effectiveness. So, for example, if you have a new release of Lego Ninjago on Netflix, how is that performing compared to, I don't know, Barbie or whatever other cartoon is for children at the time, right? And then the last one is demand forecasting. So trying to be ahead of the curve, which I guess the team had a lot of fun in Corona times
Yeah,
because
it's very difficult now, I imagine.
there was no curve. It was just a peak, and it's like, well, we are running out of stock everywhere, so that's it.
Yeah.
Yeah. And then we, of course, have an incubation team as well. So the incubation team is trying to analyze different areas, sectors, and departments at Lego where automation could be very beneficial, for example, using machine learning. And one of the examples is this brick sorter using a treadmill. Well, it's a bit more high
Yeah.
scale, but that's the idea, right?
Nice, nice. With the you mentioned the moderation app. It reminds me of a recent interview that we published with someone who works in cybersecurity, and in that environment, as you can imagine, is kind of very adversarial. You plug one hole, someone's trying to poke another. Moderation in your environment, is it quite the case that there are bad actors, as opposed to, like, are you is the task primarily identifying um passive behavior that you don't want, or are there bad actors, so to speak, that are trying to abuse the system?
I think there's a bit of both actually.
Mhm.
Generally speaking, um, we see the cases where maybe you had the phone in your pocket, right, and accidentally you took a picture. I mean, it happens to everybody, right? And then you post a picture by mistake. And that happens quite often. Sometimes we also actually caught some bugs in the app because it's like, well, is it normal we're getting, I don't know, 1,000 black images or full white images? No, it should not make any sense. It's like, okay, well, maybe you should look into into the latest release you made. So that was a funny fact. But also, and that's maybe a bit above the where our product goes with the moderation product. and that's more on on the manual moderation because they do track behaviors and bad actors. And as far as I know, I think there's been a couple of cases where somebody got banned, they opened more accounts, they keep doing the same, got banned again. The game, basically.
So there's a little bit of that. I was curious if that was a something that you had to deal with, how that played into the way you approach the model development. But it sounds like that's kind of downstream of what you're doing.
It is because it is again, we are not Facebook or Instagram, right? We need
Mhm.
to make sure nothing bad gets published.
Right.
So that's why there is the extra layers of security here.
Do you incorporate the input of the human moderators? Like, is it a kind of a human in a loop type of situation where you're using their judgments to evolve your models?
Yeah, yeah, that's right, and that's something we started doing. I think at the beginning of this year, maybe the end of last year. With the Corona year, everything is a bit distorted for me in the calendar. But what we managed to link was this external moderation company. So when they reject an image or a text or a video, we get the feedback back saying, okay, this content was rejected because of this. And what we did is we made a feature store, and that's a very simple reason for making a feature store rather than just a database, I guess. It's that the data by law, so GDPR, it cannot be stored forever. Meaning that let's say you are a user of the social media, and one day you call to consumer service and say, "Hey, I want all my data to be deleted." We cannot have this link because in a way a standalone product, right? So we are not linked to the app. Meaning, if you called consumer service, you said, "I want my data deleted." Your data is deleted, but nobody's going to tell us, "Hey, this user called because." Well, first of all, I don't have your user ID, for example, so it will be impossible for me to track who you are. But what we accomplish with this also is we generate features, and the features are generated by well-known machine learning algorithms. For images, we're talking ResNet 50. For text samples, we're talking about multilingual bird, for example. So in that sense, we get the images, text samples, we get the features out of it, which are anonymized because if you have pooling layers in a neural network, right? You cannot undo a pooling. You could, but you would not get a one-to-one match, right? And then those features are saved and then labeled with the human in the loop.
Got it. So rather than saving the original images, you're saving these representations from these neural nets, and the one of the driving reasons behind that is to um, kind of avoid the GDPR responsibilities if that was personally identifiable data.
Yeah, and whether it is or it is not, if the user calls and wants the data deleted, it needs to be deleted.
Hmm.
Otherwise, yeah, you're breaching the contract. I guess, yeah, I guess that's also within the GDPR. Um,
Meaning, if they call whatever the consumer GDPR line is and ask for their data to be deleted, these representations get deleted from the feature store.
Not the representations because they are
Oh,
anonymized data. So that's fully anonymized data.
right, right.
There is no way to backtrack where, who, and what it comes from.
Yeah, yeah. And so you said that you described that as a rationale for a feature store versus a database, but you could still put those representations in a database.
Well, yeah, I guess we like to make a fancy word, so I can just call it a feature store rather than a database, right?
Yeah, and I say that to probe a little bit deeper into that. And are there other capabilities that you've built into this feature store that are specific to the way you're using it for machine learning?
Yeah, well, so as I said, right, so the features, which is anonymized data, gets labeled by by the moderators. In this case,
Mhm.
it's so actually we have labels for the moderation part, but we also have labels for the theme part. Now, as I said before, so the images that are approved, they are published on the application, right? Which I mean are open source, or not open source, but they are open to everybody because they come from a backend that publicly shares the images, right? So then what we do for this, for example, is that those, rather than keeping the features, because that model is a bit more complex, we keep a pointer to where the image is stored in the database for the application, and then we reuse that. If the image was deleted by the customer, well, we don't have the image. It's a pity, but it's not there. But at least it's not our problem anymore. What we do with this feature store, and actually it's something we're currently working on, hopefully to be done by the end of the year, it's yeah, so retraining pipeline plus A/B testing framework as well, with both actually. So the idea is checking this feature store every now and then, right? Okay, do we have enough features for retraining, the person detector, right? Yeah, we do. All right, then let's retrain before we launch it live, even though we think the model is better, right? Let's have an A/B testing where both models are running in production at the same time, and then it's up to, of course, us as developers, but also part of the business side of moderation to decide, all right, the new model is better, or no, the new model is not better.
Mhm. With the A/B testing framework, I'm curious how you're kind of packaging and deploying the models.
Yeah, so for a model experimentation and model registry, for example, we use the open source version of MLflow, which is the, I guess, yeah, the package from Databricks. Um, we What we did is we created our own, yeah, model store with the MLflow backend, and then within the model registry, so we have the models in either production or staging or of nothing. And in the core of moderation, the core of moderation is built upon a step function in AWS. So what we have in this step function is, okay, I have the person detector here, and if I have a staging model for the person detector, then the task is a parallel task where the inputs will flow towards both, so that I can have a one-to-one analysis to say, okay, which model is performing better in all of the images, right?
Okay. And so you mentioned step functions. Do you use serverless technologies pretty broadly in deploying ML?
Yeah, I think, and that's also one of the biggest changes we did. I think this year it's been quite a change year. I think we are a full-on serverless, so everything is deployed with AWS SAM, for example, and then everything is, yeah, step function, Lambda. We have also an ECS Fargate running for the biggest model,
Hmm.
but that's generally it. So yeah, you could say everything is serverless.
Interesting. And so I'm curious how you mentioned it sounds like you're evolving the infrastructure. You've evolved it quite a bit over the past year with COVID year or so. And I'm wondering if you can share kind of what the prior state was, and what were some of the drivers for moving to serverless and container service.
Yeah, so well, as I said, right, so the moderation product started 2.5 years ago, and when we started, we thought it would be best if we tried to manage everything ourselves, which meant, all right, let's go full on lambdas, and then rather than having step function logic or things like that, let's go SQSs, SNSs, dynamos with streams. If I had a picture of the old setup, I think you would be scared, and many people maybe listening also would be scared to see that image. But then that evolved a bit into, all right, let's go ECS. So let's go full on Fargate tasks. The problem in that scenario is that we, in the moderation setup, because the application is uh, I was going to say deployed. I guess the moderation exists in 26 markets. We get data constantly, all day, every day. It makes no sense to have a Fargate task that is stopped and then has to be started when new data comes, because there's data coming in maybe every 2 or 3 seconds, which meant that the Fargate tasks are running 24 hours a day. And then for the Fargate task, which is basically a Docker container, right, to receive whatever that needs to be moderated, is that we needed to then enable a queue. So then that queue would get some data, and then at some point in the thread looping, right, you would get the message. I mean, it worked very well. Everything was perfectly fine, and it was not a big deal. But then we considered that whenever we get new employees, new colleagues in my team, it's hard to explain the flow. It's hard to explain, or maybe yeah, try to understand what is happening, right? Uh, and I think it was in December 2020 that AWS SAM came with an update. No, not AWS SAM. Lambda came with an update where you can deploy your custom Docker images to Lambda, and that just yeah, that made our work much easier. Life was better that day. Um, because what we did is, well, we have the Docker images already. Let's just transfer them to Lambda because we know how Lambda works. Lambda is amazing. AWS, not sponsored, I'm going to say now. But having the Docker containers running in Lambda, then we could also integrate it into the step functions without having to have task tokens waiting for the callbacks and a lot of complications, right? And effectively, what this meant and what this means up to today is that today we can deliver responses under 10 seconds when we talk for many images with comments and everything. Whereas before we were below the minute. So we actually managed to reduce the average times from a minute to 10 seconds, which is quite the accomplishment, I think, as well.
And do you run into runtime constraints for using Lambda when you're doing image inference?
No, no, and that's because so what we do, and as I said, right, so the feature store, right, again, and linking back to the feature store, so the images they are passed through a ResNet 50 without the classification layer, which is I think a very common approach, right?
Ah,
Transfer learning.
you've already got the representation and you're just doing classification on
Exactly,
the pure
and
vector.
it's funny because there was the Tesla AI event a couple of weeks ago, maybe a couple of
Uh-huh.
months ago, where they mentioned they are doing yeah, classification, image classification with something called Hydra. And what is Hydra? I mean, it's just a ResNet network
Hmm.
where then you have different heads which classify different things. And I was like, wow, this is exactly what we do.
Yeah.
Why didn't I think of a cool name like that before?
We've talked quite a bit about the feature store. Um, can you talk a little bit about how that evolved or any challenges you have run into in bringing that project to fruition?
Yeah, so the feature store was, I think it was, one of the biggest problems was from idea to reality, actually. Because we were like, of course, a feature store makes a lot of sense, right? I mean, if you want our models to improve, you need data, you need labeled data, right? And I guess that is the suffering of every ML engineer, right? It's not about the data. There's plenty of data in the world. It's not, but it's not labeled, right? That's a problem. So the ideation was there, but we were. It took us quite a period of time to try to figure out what's the best approach. How do we do this best? Also future thinking, because it's like, well, I mean, I could just get all the data from the manual moderation and stack it up in some, I don't know, OneDrive, and let it rot there forever, which is what a lot of people and a lot of companies do with the data. I'm afraid to say. But then we came to the realization, and I think it was also reading some posts on other companies, how I think maybe it was Uber actually, how they did feature stores in Uber. So then we came to that, to making a feature store client. everything we do is in Python. So it was in Python as well. When using the backend as AWS because we are full on AWS. But of course, we try to make it also cloud agnostic so that if one day we move to Azure or we move to, I don't know, any other else, then there's not that many problems or it can also be integrated, right? And I think one of the learnings also we got in the feature store in the first steps is that, all right, I have features. So let's say the feature, right, it's an image that went through ResNet 50. So we go from, I don't know, a couple of megabytes image to 7 kilobytes feature array, right? And I know it because I've seen many of them. So I know it's 7 kilobytes. We thought, all right, because we're going to get a lot of data. I think on average, we get around 10 to 15,000 images per day on the validation platform. So you can think, right? So 10 to 15,000 images per day, 10 to 15,000 features. Let's store them in S3. So we store them in S3, and then we have a catalog in a NoSQL database, which is DynamoDB in Amazon Web Services. Everything was fine. The data is storing. It's increasing in numbers. Everything looks to be wonderful until the day we want to query the data for the first time because we thought that let's see how the querying works. Well, it turns out that S3 is not the ideal scenario when you want to query a lot of small files because there is, and I'm not an expert in this sort of infrastructure things, but there's all of these handshake things that come between requests and getting the data. That was taking longer than actually fetching the data itself, and because there's a
What?
lot of
Why was the querying against S3 and not the Dynamo?
well, the Dynamo was a catalog. So in the Dynamo, you would be like, okay, this is the feature path on S3, and this is the label. So you
Hmm.
just need to get the data from S3 because that's on in our eyes, it's where data is supposed to be stored is in a bucket
Right.
rather than a table.
So the
But yeah,
problem that you ran into was just the latency for requesting a single file in S3 when your bucket had a lot of files.
yeah, exactly. And also requesting a big data set or a big feature data set, right? Because I guess for a couple of hundreds of
Ah,
features
right.
doesn't matter. But I think that one of my colleagues did the calculation, right? So it was, I think, 40 milliseconds per feature, and I'm not exactly sure of the number now. But
Okay.
what we learned is that well, we probably need to look into something else. So what we did is migrate the data itself as well to DynamoDB, so that the
Mm.
catalog, because I mean the feature can also be converted to a bytes array. So then the bytes array can also be stored as
Hmm.
as a NoSQL entry, right? So by moving the data into the catalog itself, what we managed to do is that the data now is fetched 16 milliseconds per feature, which is halving the time, and that had actually proved to be very efficient actually. So
Is the data community there at Lego? Um, is everyone kind of full stack, or do you have your more traditional data scientists and then folks that are more ML engineers? How does the what's kind of the range of skill sets or culture there in terms of full stackness, if that's a thing?
full stack. We are very happy we have a full stack developer in our team because he's a mastermind in doing our front end tool.
Hmm.
Before we had him, I think our front end app was maybe something out of university, you could say. Um, but so we are split actually. So we have, like myself, so we have machine learning slash data engineers, you could say, right? We also have the more standard data scientists as well. And then we have data management folks and platform people. So the ones that are helping with the more standard infrastructure, like setting us the account, the the security, and all of the yeah basic things that you need when you are an enterprise company, right?
Interesting. We haven't talked in detail about the engagement tool. What were some of the interesting challenges you ran into in developing that tool?
Well, there's also been a couple, right? Because when you come out fresh from university, right, you think data sets are beautiful, clean, and I think that's what a lot of people think, right? And because when you read research papers, the data is just beautiful, right?
Yeah.
And you have, I don't know, 16 GPUs and all the money in the world, apparently. Well, that's not our case, even though it also goes well, I guess, monetarily speaking at Lego. But I think one of the main issue, this all started. So the whole idea for this engagement tool started also maybe 2.5, 3 years ago. And their initial idea was that we would get the data to then train only image. So we started only with images to train an image classifier that could recognize themes. Then the constraint was we want this algorithm to be on device. Um, so what we did is we went for the smallest network known, which is, well, at the time was MobileNet V2, I guess. And that's 5 megabytes. And that was too big for them. So then we had a problem because it's like, well, we can try to go down, we can try to minimize, we can try to reduce weights between layers, we can try to all of these sort of optimizations, but the results were already a bit clumsy. So you maybe had a Jurassic World build, and I would recognize it as Star Wars. So it was far from idea, and actually the idea of the project stopped there until a couple of months after somebody said, well, why don't we try to do this theme detection for actually interacting with the customers or with the users? Because then it's like, well, you have room to do the network you want. We don't really care because it's just going to run in the cloud, and it's going to run after the fact, right? So it's going to run at some point in the day to just get the themes and send some likes and comments, right? Um, and that went very fine. I think we started with 5 themes, which is the top 5 categories also from the application. And probably the biggest issue there again was the data quality, right? So you can think of our application like the Lego Life app as Instagram, right? So when you're a user, you take a picture of your Lego build. You will write a title and a description saying, this is my cool creation. This is a Star Wars shit fighter, whatever. And you can also then add tags, hashtags, like on Instagram. So those hashtags could be, hashtag Star Wars, hashtag, I don't know, a lot of other things. So because this data is available in the social media's backend, in this sort of, you could say clumsy labeling, we said, all right, well, we could try maybe running the first iteration, trying to crawl all of this data with some specific themes and maybe also even keywords we know are used for specific themes, right? So let's say, okay, if if a user has published a Star Wars image and says this is Chewbacca, I know Chewbacca is a Star Wars minifigure. Well, I can probably make it in my data set saying it's Star Wars. So that's how we collected data the first time for 5 classes, and it worked wonderfully well. There were also a lot of misclassifications, but that was also expected from us. And we tried to clean, so we tried to, I think we did a couple of iterations on the keywords and the hashtags we used as well. Because you could think, if you said spaceship could be Star Wars, but it could also be Ninjago, could also be City. There's a lot of different spaceships. That's the problem at Lego, right? That imagination is the limit, right? So it's not the real world, unfortunately, or fortunately. It makes it a bit more fun. But yeah, so then we got the data. The first model with 5 classes worked. It was accepted by the business side. And after that happened, then we extended to 10, no, 9 classes. And then now we're up to 13 classes. And I think the latest issues we've been having, or not issues, but the latest challenges we had to overcome was growing to 13 classes. Now we have a 3 terabyte data set of images, which you might think, well, it's not that much. There's like ImageNet has 15 million images, I guess. It's quite a bunch when it's the first time we work with such a big data set for a production ready solution, right? And using SageMaker, we also learned a lot of SageMaker because we don't have on premise GPUs. So well, I have it here, but I have it for gaming on my free time. So we also had to do some learning on how to utilize SageMaker the best possible. And to be fair, that also was very helpful when we also got support from them from the enterprise side, because then yeah, so we were using SageMaker notebooks, which is just a full-on Jupyter notebook. It turns out that even though you can choose a GPU instance for the notebook, it is not the recommended scenario. The training on a GPU has to be done on the SageMaker training step. The notebook is more just for data prep and data visualization. Well, we didn't know that until, of course, we needed to run this 13 class training. Actually, the 9 class training, we did it on the SageMaker notebook. And I think it took, what did it take? A week, maybe? A week and a half. Whereas for the 13 class, we then got these estimators running on the training jobs. And that took, I think, half a day. So more data, less time.
Yeah.
It was a good trade off, I think.
Got it. Got it. Um, Very cool. Very cool. What are the kind of what's next at Lego with ML? What are you excited about or looking forward to?
I think I think it's a very open question, right? Because again, so we are a company that makes a lot of, I guess, out of the ordinary things, right?
Hmm.
And one of the projects, for example, we've been looking at is a taxonomy list, right? So let's say how many cars we have, how many motorbikes, how many dogs, how many cats we have at Lego, right? And you could say, well, we are Lego, we own all of our data, we know what we have, and that's true. But what is, well, who is telling me that tomorrow there's not going to be I don't know, a unicorn with fish legs, for example,
Right.
right?
Sure.
So this makes this taxonomy a bit complicated, right? Because how do you evolve an algorithm or a set of algorithms that can get a new class that has never seen before? It does not look like anything, right? Because you can have a fish and a unicorn, but if they are combined, who's the winner here, right? How do you make sure that your algorithm can learn the new classes that come in? And it's something we're looking into, and I think it's hopefully coming next year. It requires a lot of prep work, that's for sure.
Mhm.
But there's also a couple of other things. So we're also trying to upgrade some of the AFOL, which is AFOL is an adult fan of Lego. So all of these adult-oriented experiences, we're also trying to put on a bit more spice to them for making it also exciting for the adults to use.
Okay.
Saying, "Oh, you can have your this specific application here. Can you recognize what you're building?" Things like that, right? So trying to interact with the users as well.
Very
But
cool.
it's complicated, I think, right? Because you can have very big dreams, but it's always bureaucratic, right? And it's always
Hmm.
about the data, right? It's like, well, sure, you can ask me to classify all of the red Lego bricks you have, but I need to know what a Lego brick is first, right? And what is red.
Right. Very good. Very good. Well, Francesc, thanks so much for joining us. It was great learning about your projects and especially how you've built out the platform and infrastructure to support them at Lego.
Yeah, and well, thanks again for having me. And I guess maybe one last learning: you don't need to go Kubernetes. You can always go serverless.
Awesome. Thanks so much.
Yes, thank you.